Okay, so like I said, today we are graphing linear inequalities instead of linear equations. Go ahead and throw your name on here. It is currently first hour. Okay, so for a linear equation, when we have been graphing a line, a solution to that line, a solution to that equation, has been every single point along that line. Now that we are graphing inequalities, we have more solutions than just what's on the line. A solution to an inequality is in the shaded area of a graph. So we are going to have either above or below the entire graph shaded, and that is where your solutions are. Once we find a solution, those solutions are going to be written as ordered pairs. Okay, we have 4 different types of things that we will have for our line types and our shading. So we have 4 different inequality symbols. So instead of just having an equal sign, we have the less than, the greater than, the less than or equal to, the greater than, the equal to. So this is when we are going to use types of lines for each of those. So we are going to use a dashed line and shade below if it is a less than symbol. We are going to use a dashed line and shade above if it is a greater than symbol. Okay, we are going to use a solid line and shade below for less than or equal to. And we are going to use a solid line and shade above for greater than or equal to. Okay, so the dashed line is same as if we were using an open circle. So we used an open circle for less than or greater than. We use a closed circle for less than or equal to and greater than or equal to, so that's what the same as a solid line is. And what we mean by a dashed line and a solid line is when we go graph it, we're going to graph a dashed line or we're going to graph a solid line. Okay, and I put a little note there. Points on the dashed line are not solutions. So if it is on the dashed line, that means you have to be either greater than or less than for that to be a solution. If it is on a solid line, it can be greater than or equal to, less than or equal to. So those are a solution. Okay, Alakai, grab a note sheet, please. Hey, so we are going to graph each of these. What we have to remember is what type of line we're going to use and whether we're going to shade above or below for where all of our solutions are. But other than that, the graphing is the exact same that we've done in 2.4 and 2.6. So the first one we've got is y is less than negative 2/3 x plus 4. I put little blanks here so you could figure out and keep track of things. So for a less than symbol, my line type is going to be dashed, and I am going to shade below. So line type dashed, and shading happens below. And then from there, I just graph this line, connect it with a dashed line, and shade everything below it. So I've got y is less than 2/3 x plus 4. So I'm going to start at a y-intercept of positive 4. And then my slope is negative 2/3. So I'm going to go down 2, right 3, down 2, right 3. Down 2, right 3. Down 2, right 3. I can also go up 2 and left 3. I've been saying all unit, you need to draw your lines all the way across your graph. this is y. To be able to shade above or below, we have to completely chop it in too. So once we get those dots drawn, when we go to connect, you're going to connect it in a dashed line. So don't just it. You gotta go like every other. And you can still put arrows on the end because that still would continue forever. And then our solutions are everything below that. So we can shade everything in below. And you don't need to color it in solid. You just need to shade it in. Oh my gosh, well, my pin's not working now. You just need to shade it in enough we can tell that it's this side is shaded. So you're shading everything below it. Okay. Any questions on that first inequality we graphed? Hey, let's look at the next one then. We've got y is greater than or equal to 2x minus 5. So the first thing that we can look at is that greater than or equal to symbol. Greater than or equal to tells us that we need to shade above a solid line. So line type is solid. Shading is above. So we're going to graph that 2x minus 5. We'll start at negative 5 on my y-axis. And then my slope is 2, meaning I'll go up 2, right 1. Because anytime the slope is not a fraction, we can put it over 1. So up 2, right 1, all the way across my graph. Okay, and then we can go ahead and connect those into a solid line. Then we need a shade above it. So sometimes the steeper a line gets, the harder it is to figure above and below. Think about if you were skiing down a mountain, you would be above it. So if I were skiing, even if it was really sloped, I would be on this side here. I wouldn't be upside down on the other side. So this is above. Right. Any questions on either of those problems? Right, flip this over. We got 2 on the back. They're horizontal and vertical. As a nice little review of that, because there's some of those on your assignment. So, I know in our acronym we said y equals, but y is greater than or less than would be the same thing. So this first one, since it's y, that is going to be a horizontal line. You want to put a little note to yourself that that's horizontal, you can. So the type of line that that's going to be for a horizontal line, since it's greater than, for a greater than symbol, we do a dashed line. And since it's greater than, we're going to shade above. And you've got your little table on the other side that you can use that for. So dashed line, greater than, shades above. Okay, so we'll do a dashed line at 4. So y is greater than 4. So here's 4 there. So that's on our y-axis is where we start that. We'll do a dashed line. And then we can shade everything above that. And then our very last problem, x is less than or equal to -2. If it's just an x, we know that's going to be a vertical line. It's going to be vux. So it's going to be a vertical line. Less than or equal to, the or equal to tells me I need a solid line. And then less than means I shade below it, which is kind of tricky on this one. So less than or equal to -2. I'm going to go on my x-axis to -2. And graph a solid vertical line there. And then this is the only one where, like, thinking, am I on top of a mountain or below a mountain? Hell, or does it work? And you just got to think which direction's positive, which direction's negative. So on my x-axis to the right here, 1, 2, 3, 4, 5, 6, this would be positive. So this would be above. This is below, because this is where the x values are smaller. So it's the one time that above and below doesn't work out perfectly. All right, any questions right now? Okay, go ahead and glue this puppy in then. I'm going to stop this video. Those are still